so we're going to continue our work on the hydrosphere. So who can remind me, so last week we started talking about, we have our what are we learning in science, we have our what are we doing as scientists, and then we're making the connections. Can anybody remind me or talk to me about where we have done any of these 3 dimensions of science? Brady?
Asking questions.
And when have we done that?
All the time.
Okay, all the time? Good, and I remember specifically we started our solar system and you guys asked great questions about the moon and the planets and the sun. Lexi?
Developing and using models.
And when have we done that?
The toy project.
Good. Morgan?
We worked on planning and carrying out investigation.
Yeah, and when did we do that?
With the fish being gone.
And what about with evaporation? Did you guys plan your own?
Yeah.
Yeah.
Yeah, we just did that with evaporation. You guys planned your unit and then you watched what happened. Okay, so now these, I'm going to show you kind of the connection. So this is our learning target for today. I will develop and use a model to compare the different amounts of fresh and salt water in the world. So what we're starting to talk about, and we've kind of been talking about, is the hydrosphere and all the water. So today we're getting specifically into comparing fresh water and salt water. So look at my different colors here. And now if I go back, so the 3 colors I have right now on my screen are
Black, green, yellow.
blue, green, and yellow.
That's okay.
Oops. Or orange, blue, green, and orange. Okay, so then when I come here, I've got my blue and I've got my green and I have my orange. So we're gonna kind of come back to this more at the end. But as I break apart this, I will develop and use a model. So this is what you guys are doing as scientists. This is how you are thinking and acting like scientists. Today, you're gonna be developing and using models. Just like you did when you did your solar system project. And then we're going to compare the different amounts of fresh and salt water around the world. So this is what we're learning about as scientists. Fresh versus salt water. And we're making those connections as we compare those two and we look at our Earth and how it relates to us. So the first activity that I'm going to have you do is with your team that you're sitting with. You are going to make a list. Let's see who can get let's see which group can come up with the biggest list of everything that you need water for. On a daily basis, on a weekly basis, what is it that you use water for? So 1 note card per team, pick somebody to be the writer. Let's see which team can come up with the most items of what you use water for.
We have drinking, pool, showers, baths, hand washing, brushing teeth, gardening. That's what do we have so far? Drinking, swimming, bath, shower, cooking, brushing teeth, washing dishes, washing your hands.
You guys start. What's one thing and we'll go around. Ironing. Wow, that's a good one. Yeah, we got to add water to the iron before we get started. Caitlin, one thing from your list.
Showers.
Showers. Yes, I hope so. Peyton.
Need it for like food. Like,
Yes. What do you mean with food?
like if you're gonna make a cake or if you're gonna like cook, you need water.
Good. We talked about that in this group as well. Some of the recipes that we use call for water. Right here.
We have ice.
Okay, good. And what do you use ice for?
You put it in your water to make it cold. Or any beverage.
Okay, good. Right here, Jaden.
Toilet cold.
Okay, good. So going to go to the bathroom, we need toilet water. Good. So as you can see from those lists that we've done, water is very important to our everyday life. So we're going to get into now looking at, remember that original learning target, the amount of fresh water versus salt water. Here are some fun facts. So 1 in 10 people in the world, so we're not thinking of just the United States, we're thinking of the entire world. 1 in 10 people in the world lack access to safe water. Every 90 seconds, a child dies from a water-related disease.
What? Every 10 seconds.
Okay, next one.
90 seconds.
1 in 3 people lack access to a toilet. More people have a mobile phone than a toilet.
That's what? That is.
So as you guys created your list of water, for us here in Cedar Rapids, Iowa, and the families that we live in, water is very accessible to us. If we need to drink it, if we need to water our plants, if we need to feed our animals water, if we need to give them water to drink.
Oh, take that.
Water is very accessible to us. As you can see from these statistics, maybe if we're looking worldwide and even other places in the United States, water isn't as accessible. So around the room,
3-minute timer.
yep, around the room, I have 5 different posters. So we have an I Notice, I Wonder station right here, and I Notice, I Wonder in the back, right there, right here, and then this one I'm gonna move to that middle table here in a sec, so we spread out. So at every single table, there is a image that you're going to, when you're at that table, because you are going to get up and move, you're only focusing on the image that's at the table. So right here, it does have all 5 images on the side of them. I really don't want you to look ahead at the different images. This is just to help you keep it sorted. So if you're starting at this table, this is actually the top image. So you're gonna put your I Notice, I Wonders right next to this image. But if you're starting over here, this is the bottom image on the I Notice, I Wonder chart. So you're going to start writing down at the bottom. And then you can kind of make it work. I know there's not a ton of space, so you're gonna have to write kind of small and squeeze in and see if you can come up with a couple I Notice, I Wonders at every single picture. And then you will rotate to all 5 pictures and you'll carry this with you. Any questions about this? At the station, you have 3 minutes. So take turns being the writers, but each poster, have a conversation. Try and figure out what is the picture trying to tell us, what are our questions.
And I notice is he has dirty water, and he has a water bottle with dirty water by a stream, and then my wonder is, did he get the water from the stream?
I wonder why there's not a lot of grass.
I wonder what happened to the
grass.
I noticed that there's like a lot of tiny buildings with big hands reaching up towards the water droplet, and then I wonder, like, are they having like a drought and they're trying to get like the last bit of water that they can because it's a drought?
Okay, so here's what we're gonna do next. Out of all of the pictures that you looked at and all of the questions that you have, as you looked at these different images of water, as you looked at each of them, and you can see them on the side of your poster, we're going to go back, and now as a group, I'm going to give you 3 sticky notes. You are going to pick your top 2 or 3 questions. Whether they are on your poster or you think about now everything in general, everything you've seen. What are you wondering at this point? What are you hoping we learn about? What are you hoping to find more out about? If you were going to research, what is it that you're wondering about water? We had the fun facts, we had these pictures, we talked about human impact yesterday. So as a group, 2 or 3 questions, 1 per sticky. Here's where we're at right now. Oh, you keep them. Okay, so we as a group, you had all those questions generated from I Notice, I Wonder. We thought about all the things that we've looked at and have been learning about, and now we've narrowed it down to a few questions that we want to know more about and investigate. Would anybody be willing to raise their hand and share the questions that you have? And we're going to add those over here to our investigate board. Lydia.
I wonder why we have so much salt water and barely any fresh water.
Okay, perfect. Can you bring that up to our investigate board? So she was looking at that graph that we had and wondering why is there so much salt water and so little fresh water? Great question, Lydia. Brady had the same question. Brady, can you come put that up here under that sticky note? Does anybody else have a question that was similar to Lydia's or Brady's?
Yeah.
What was yours, Haley?
It was, I wonder why salt water and fresh water.
Perfect. Come up and add that one up here as well. All right, who has another question separate from the salt water versus the fresh water? Let's go with Aiden.
I wonder where that boy is.
Okay, so the picture right here, the image with the, and a lot of you had questions about this one, the wonder with this, where this boy, so Aiden's wondering where is he living, that this is where he's getting his water. So Aiden, go ahead and bring that up. Did anybody, raise your hand, did anybody have a question similar, wondering where is this boy living, something about this boy? Addison, what was your question?
I wonder where did that little boy get that dirty water from? Did he get it from the stream?
Okay, all right, go ahead and add that one up here. And we'll put that under kind of our salt water versus fresh water. All right, what other questions do we have left out there? Aiden.
What happened to the plants that disappeared?
Okay, so Aiden's talking about this image right here, and he's asking specifically, what's going on? Where are those plants at? Go ahead and bring it up here, Aiden. Any other questions that need to be brought up to the question board? Raise your hand if you still have a blue sticky note. Just Jaden? Okay, Jaden, what's our last question that we're wondering about?
It was about all the people reaching for that drop of water.
Okay, what are you asking, Jaden?
When will something like this ever happen?
And can you explain that? What do you mean by that? I know you told me this earlier.
Like, will there ever be like a point in the world where there's only one drop of water?
Okay, and maybe just, yeah, that limited access, is there ever going to be a point where there's lots of people needing the same water? And is that already happening in certain places? Jaden, go ahead and bring that last question up here to the question board. Nice job, you guys. We've got a lot to explore and learn. Okay. So go back to the back and we're actually going to start a lab target. And this is where we're just getting to this part now. So we've kind of got you hooked. We've got our idea. We're going to go back to, we need to develop and use a model to compare the different amounts of fresh water and salt water. So that image that I showed you, that graph, we're going to kind of look at that now, and we are going to create a model of all of the water on Earth. What I'm going to ask of you in your group is that you carefully go, when you get back to your lab, you are going to go step by step on your direction sheet to be able to accurately create a model of all of Earth's water. So here are my directions to start. Welcome, scientists, to the Water Distribution Lab. Today you are going to be creating a scale model. Are we able to take all of the water on Earth?
No.
And look at it here in our classroom? That would be hard. I think that would be
We would drown. Like we would drown and it'd probably go out there.
right. I think, yeah, we'd be in trouble. So instead of taking all of the water on Earth, we're going to create a scale model of water. It is really important, as I just said, for you to follow each direction. So you're going to start with direction 1. After you complete it, maybe you would even, as a group, put a check yours. You guys get the...
Did you not have two of those? Did you not have
90% of the water on Earth. And now we're going to divide our water into 2 types. Fresh water. 97% of Earth's water is salt water. How many milliliters of our water is salt water?
So 90. Don't we have 30?
Let's see if he gets the same answer as the calculator. Pressure's on.
What is this?
That is our fresh water on the Earth.
And how much is in there?
30 milliliters. This one's 970.
And what is this one? Yeah, but what's this supposed to be in your model? Salt water. Okay, so that's our fresh to our salt, huh? Your scale model.
Okay, so what do we have here?
That's 30. Oh my god, this is all the salt water?
Okay, that's a little too early.
No, but it is. It's like all the salt water. That's a lot.
And so what percentage is salt water on Earth?
Isn't it like 97?
97%. And how much is this representing? 3%.
The fresh water side.
All we took out was 3.
I feel very bad for using
Okay.
this water right
Can
now.
you guys tell me the like what this is here?
This stuff is made out of the fresh water. There was 30 milliliters in here, but now there's not because it all went to frozen groundwater and surface water.
So out of all of the water on Earth, where is the least amount of water located?
The least amount of water is
Fresh, and then more specifically out of fresh water it is.
surface.
Okay, can you guys show me what your graph is showing here?
So this is how much frozen water we have. Then the fresh water, we don't have very much fresh water. And then this is all the groundwater.
And that fresh is actually representing the surface water. Right? Guys, as you finish this lab and you have yours graphed, go ahead and flip it over. And you have your cups.
Yeah.
What have you learned? What's the most surprising thing to you?
Now there's so much salt water. There's a little bit of frozen water. There's barely any surface water. You know, choking on my gum. There's barely
All right,
any.
you guys. So after having everything done, what are your thoughts about our model of Earth's water?
I'm shocked that there's more frozen water. Like there's way more frozen water than fresh or surface water.
How do you think that impacts us?
It affects us a lot because I mean this is all of the water that we can get to. We take our water for granted that we have a lot, where like some countries don't have any.
We did it into fresh water and salt water, and then we took our fresh water and we divvied that into frozen water, groundwater, and surface water. So is that model that we just created with all of Earth's water, is that presented at a smaller scale, larger scale, or the same size as the actual phenomena? So the actual all of Earth's water. Was our scale smaller, larger, or the same? Talk with your elbow partner and be ready to share. Is our model smaller, larger, or the same as our phenomena, as our water that exists here on Earth? Aiden? Aiden says smaller. Aiden, what do you think? Way smaller. Like what we just did with when we did the solar system, we obviously could build a toy that was the size of the solar system. So we took the solar system and we said, well, here's our model. The sun has to be bigger than the earth, and the earth has to be bigger than the moon, and we created a scale. So with this, we created a scale model as well. We took all of Earth's water, we scaled it down to 1,000 milliliters. So much smaller. We worked with a much smaller amount. Okay. Looking at our water model, so then when we examine, if we go back to just fresh water, salt water, how does the level of salt water, how did that salt water compare to our level of fresh water? So we take all of the water and we split it into salt water and fresh water. How do those two compare? Salt water versus fresh water. I have 3 people with ideas. Lydia, how'd those compare?
Like, really, like, compared to each other, like, the salt water is super, like, a lot of salt water, and then there's, like,
Okay, and I'm telling you guys, I didn't make this up. I didn't create this as like, oh, I'm just gonna show them, I'm gonna pick some random number as salt and I'm gonna pick some random number as fresh water. It actually matches this graph right here. It truly is, in our Earth, 97% of our water is salt water and 3% of our water is fresh water. So what you just did, and you saw that beaker that had this much water, and then the graduated cylinder that had this much, that's actually a comparison of salt water versus fresh water on our Earth. So with that in mind, my last question for you, does this information and what we did today, is there anything that surprises you? Is there anything that stands out to you? Are there any concerns you have moving forward? What did this lab make you think of? Morgan?
I'm sure that pretty soon there won't be enough fresh water.
Okay, why?
Because there's only 3% of fresh water and 97% of salt water, and people keep using up fresh water.
Okay, good. So she's concerned that what if our fresh water runs out? We're already at 3%. What happens then? Jaden, what are your thoughts?
I am concerned because when climate change actually destroys all the ice in the world, there's going to be like probably 1% of fresh water and 99% of salt.
That actual and some of that water that's locked in icebergs. What actually type of water is that?
Salt water.
Fresh. Okay, good. So we have some thoughts here. If we have this much salt water, why haven't we, or are there ways that are already been developed that we can take that salt water and make it so it's accessible, make it so it's fresh? And that's what we're going to keep learning about. Is that possible to take some of this salt water and use it? We know that as in the form that it's in, as salt water, would you want that in your food?
Yeah. No.
Have you ever, if anybody's ever been to the ocean and swallowed salt water?
I know.
I was thinking what's going to happen to our population if we do run out of fresh water, and will it run out in my time of living on Earth?
Good. So Addison's wondering, is it possible that like if this continues to decrease, what's going to happen? And what's happening to our population? It's going population's going up and our water amounts. So we've got to make solutions. We've got to figure out ways. Okay. Last thing for today. So coming back to, here was our learning target for today. We wanted to be able to take all of Earth's water, 100% of it, and create a scale model to compare the different amounts of fresh water and salt water in the world. Coming back to this, the last task I'm going to have you do with your group. I'm going to give you 3 sticky notes. You're going to pick which of these disciplinary core ideas do you think we were learning about? Were we learning about physical science, and don't say it right now, life science, earth and space, or engineering and technology? So on your sticky note, you're going to write which one you think. Then, over here, you're going to pick what do you think we were doing as scientists? What was our science and engineering practice? Were we asking questions, developing models, planning and carrying out investigations? Which one of these? And you're going to write that on a separate sticky note. And on your third sticky note, this is probably the toughest category for us to identify. Try as a team, and there's no right or wrong answer right now. This is the first time you guys have ever identified. Go ahead and see, where do you think we were in our cross-cutting concepts? Right, so 3 sticky notes as a team. Go ahead and write 1 for each, and we're going to come up here and put them on our chart.
No, it's actual physical on Earth. What? No, if it's on Earth, maybe we do Earth and space science.
Okay.
Our water is changing.
Our sticky notes.
Oh, you scared me.
Oh my god, I feel
All right, so let's see how you did at identifying how you use 3-dimensional learning in science today. All right, how we used them. So over here, what did we learn about today? I have lots of you that identified life science, life science, life science, life science, and then this one actually says life science as well. Can somebody raise their hand and tell me why you thought we were learning about life science today? Brady.
We were learning about water.
Is water living?
Part of life.
Water itself is not alive, but I know why people thought that. So who can share with me, why did you think life science when we were dealing with water? Aiden?
Because it's part of your life.
Okay, and living things depend on it. We talked a lot today about humans needing water, animals needing water, plants needing water. So I totally understand why we're on life science. That's great. This one is not wrong either, because if I had to identify, we kind of are still in that earth science. When we're talking about water, all the water on Earth and the hydrosphere, we're talking about an earth system. So either of these would work. As we move over to our science and engineering practices, I see developing and using models, asking questions, and I let a couple groups have 2 sticky notes. This one actually says mathematics. And then developing and using models. Okay, good. We created a model of all of Earth's water, and at the beginning of class, we asked a lot of questions, and even throughout class, you guys had really good questions. Who put mathematics?
Our group.
Can you guys explain why you did mathematics as a?
Because we had to use like number. No, not number.
Calculators. Yeah, when you were solving for the scale, you actually had to figure out what is 97% of 1,000. Okay, and then lastly, cross-cutting concepts. Very good. We had a lot of scale and proportion, which we did create a scale model of all of Earth's water. We made that proportion. Stability and change. Can your group talk about why you chose stability and change? Yep, right here.
Because the water is changing, and it's not like super stable. Like the amount of fresh water and salt water is always kind of changing.
Okay, good. So you're thinking about the water cycle and where water is at different times. All right. Good job, you guys.